Hello, Year 12s. First of all, my sincere apologies for the disruption caused to your physics learning. I can't do a 1 hour team session at the moment, so I thought I will do an audio PowerPoint, which then I can record at regular intervals depending on my health, and then club everything, all of them together. And so kindly request you to adjust with this for the time being. Hopefully I'll be back on Friday. So we had already done in our previous lessons, we had already done everything about current and charge, moving charges, mean drift velocity, all those things. With my 12C, I haven't done Kirchhoff's law, but don't worry. I will go through it when I'm back in the class. Okay, so I'm moving on to the next section, which is about energy, power, and resistance. So that is what we are going to see in today's lesson. So let's proceed. So last lesson, we saw the definition and equation for electric current. Now we will move on to potential difference. But before moving on to potential difference, I would just like to remind you that you need to inherit all the GCSE circuit symbols that you had done. And it's for A levels, it's almost the same thing except one. So A levels, you need to know the cell, battery, closed and open switch, different type of resistors like fixed resistor, thermistor, LDR, variable resistor, the lamp, fuse, then the diode, and the LED or the light emitting diode. Other than this, the only extra thing you have to know is the capacitors, but I wouldn't worry about capacitors too much now. You will do that only in your year 13. So keep in mind all these circuit symbols also. And then, so let's move on to potential difference then. So potential difference is you have come across this word before. It's not a new word for you. Potential difference is a posh way of saying voltage. And now, once you have started your A-level physics, you guys have become more posh. So you need to get used to using the word potential difference. Going back to your GCSEs, how many of you remember what you had studied about voltage? Anyone remembers what you had studied about voltage in your GCSEs, which you did once upon a time? Let's do one thing. I'm going to give you 30 seconds. You can discuss with your partner what the potential difference is going to be. Oh, I think 12A would be able to discuss it with their partners. 12D, just think about, discuss it with your brain and think about what you can remember about potential difference or voltage. I'm going to give you 30 seconds for that, and your time starts now. Okay, year 12, that's your 30 seconds. Now, what are the key words you have come up with after discussing? Can you think about, did you discuss something to do with energy, something to do with charge? If yes, then yes, you're right. So what is potential difference? It is a work done to move a unit positive charge between 2 points. So keep in mind the key words. It is the work done to move a unit positive charge between 2 points. So when the charges have to flow from one point to the other, if it is moving through even if it is moving through a wire, the wire is made of atoms, isn't it? So those atoms are going to be on the way of these charges. So if the charges have to go past these atoms, they have to use energy, or they have to do work. So that work that they are doing is what you call the potential difference. Now when we talk about potential difference in A levels, they can ask you about what are the energy changes that is taking place. So potential difference, the electrons are flowing or the charges are flowing, isn't it? So they are already having electrical energy with them. And then depending on through what they are moving, if they are going through the, if those charges are going through a bulb, it gets converted into light energy. If it is going through a resistor, the resistor gets heated up, so it can get converted into thermal energy. So the input is always electrical, and then the output will be heat, light, etc. Okay, so that is a type of energy transfer that takes place. Then in the case of potential difference, the work is done by the charge carriers. Okay, the work is done by the charge carriers because the charge carriers are the ones that are moving through the circuit. Then what is the equation? The potential difference. This equation is something you have learned in your GCSEs. This is one of the equations you had to memorize in your GCSEs, and since, as I said before, the advantage of A levels is you don't have to memorize them anymore. Now check with your data sheet whether this equation is given or not. Okay, please remember to check with your data sheet. So potential difference is the work done divided by charge. So what is the unit of potential difference? Volt. Keep in mind, volt is not a base unit. So remember to convert it into base units. Think about how you can express work done in base units, charge in base units, and figure out the final base unit for volts. Once back in lesson, I'm going to ask you what the base unit for volt is. And slightly different from your GCSEs, they can also ask you to define 1 volt. It is very much similar to the definition of a potential difference. Potential difference is the work done to move a unit charge between 2 points, right? So 1 volt is 1 joule of work done, or 1 joule of energy transferred per unit charge passing through a component. So these are the things you need to know about potential difference. So 1, the definition, which is the first bulleted point. Then what are the energy transfers that is taking place? The energy is always transferred from electrical to the other forms of energy. It's a work done on the charge carriers or by the charge carriers. The work is done by the charge carriers. Then the equation for potential difference, please check with the data sheet. The unit for potential difference is volt. And again, I remind you, volt is not a base unit. So once the PowerPoint is done, make sure you figure out what the base unit of volt is. And then finally, you need the definition of volt, which is the potential difference across a component when 1 joule of energy is transferred per unit charge. You can also say when 1 joule of work is done per unit charge. Either way, it is fine. So if you were not able to copy down all these things now, don't worry. I'll send you the link as an email, and you can copy this down at your own time. Okay, so that is about potential difference, and then moving on to the next one. From PD, or potential difference, we are moving on to electromotive force, or EMF. Electromotive force. We have not used this word in our GCSEs before, so this is a new term. Electromotive force is basically the energy of the whole circuit. Potential difference we were talking about across a component or across 2 points in a circuit, isn't it? But when we talk about electromotive force, it is a work done to move a unit positive charge once through the complete circuit. So the electrons that is coming out of the negative goes through the circuit, goes back to the positive once. To do that, how much energy is needed That is what you call the electromotive force. So here, what is happening? So think about a battery. What energy is it having? The chemical reactions taking place inside it, isn't it? So it is having chemical energy. Then that chemical energy is what gets converted into the electrical energy of the electrons. So opposite to the potential difference, in the case of electromotive force, the energy transfer is from the other forms to electrical. Potential difference was from electrical to the other forms. Here it is from the other forms to electrical. When I say other forms, it can be, the most simplest example is, say, a battery where it goes from chemical to electrical. It can be an LDR where it goes from light energy to electrical. So in the case of electromotive force, the input is the other forms of energy and output is electrical. Here the work is done on the charge carrier. So the cell is pushing the charge carriers. So potential difference work is done by the charge carriers. In the case of electromotive force, work is done on the charge carriers. So it is also measured in volts like PD, and by accident I clicked the energy transfer slide. I clicked the next slide and I've come to energy transfer. So if I just summarize PD and electromotive force or EMF, there has been past exam questions where they ask you to say the differences and similarities between potential difference and EMF. So both are energy, both are measured in volts, but in the case of potential difference, energy is, or the work is done by the charges, and the energy transfer takes place from electrical energy to the other forms. In the case of EMF or electromotive force, the work is done on the charge, and then the energy transfer is from the other forms to electrical. So they can, I have seen a couple of times, I have seen this question where they ask you for the similarities and differences between PD and potential difference and electromotive force. Then energy transfer is easy. So we are just the previous equation we saw for potential difference, V equals work done divided by charge, or energy divided by charge. From that we can see that work done is voltage times charge, okay, or potential difference times charge. In case sometimes they will also give you the EMF. In that case, work done is or energy transferred is EMF times charge. To make sure you know to use that questions, your online Kerboodle text, you need to do questions 1 to 6 on page 142, but you can do that at the end once the PowerPoint finishes. Okay, so make a note of the page number and the question numbers so that once the PowerPoint is done, you can start doing the questions. Okay, so summary questions 1 to 6, page 142 of your Kerboodle textbook. And I'm moving on to the last bit. So next we are moving on to one of the application of the energy transfer we just saw. So it says electron gun on the PowerPoint. Again, it's not actually a gun as such, but then this is a method how we produce electrons. Now, why do we need to produce electrons in that way? We use this in oscilloscopes, mass spectrometers, etc. Okay, so how does it work? This is the picture of an electron gun. So what you can see here is, you can see a heater here, isn't it? This heater is basically a metal filament. So you pass electric current through it, and you know that metals, when electric current passes through it, they get heated up. So this heater there is basically what produces the electrons. And then you know that electrons are negatively charged. So in order to attract them or make them faster, we have a positive anode there, okay, which is at a high potential. So what we generally do is we heat this heater, and the electrons in the heater, once they gain sufficient kinetic energy, they come out. Once they come out, there is a positive anode here. It gets accelerated towards the anode and the electrons come out. Now when the electrons come out, depending on what we are going to use that electrons for, they need to have different speeds. And again, based on what speed we want them to have, we adjust the voltage that is given here. Okay, this is in short what happens. Now let's see step by step. So what do we use this for? It is used to produce a narrow beam of electrons. And as I said before, why do we need these? We need them for electron microscopes, mass spectrometers, and oscilloscopes. So the heater there in the diagram, it is heated by an electric current. So whenever a current passes through a metal, we know that the metal gets heated up. So you're supplying energy to it, and the electrons that are stuck inside the metal, they take this energy and they come out. So that is what it says. Some electrons in the wire gain enough kinetic energy to escape from the surface of the metal. And what happens when it comes out of the metal in front of it? And this way of this method of using heat energy to emit electrons from a metal surface is called thermionic emission. Thermionic means thermal energy. Emission means coming out. So what is thermionic emission? Heating a metal wire to emit electrons is what you call thermionic emission. Then the electrons that come out like this, as I said before, you have a positive anode there. It gets accelerated towards it. Depending on the purpose that we are going to use these electrons for, we can apply different potential there across the anode. This value here, you can apply different values to make the electrons slower, faster, depending on what we are going to use them for. So now, how do we figure out? So they can always ask you to find the speed of the electrons that comes out of the heater, or they can give you the speed and ask you, if you want this much speed, how much voltage should you apply? So I already told you that the electrons coming out will have a kinetic energy because they are being attracted towards the anode, isn't it? So they move towards the anode and they gain energy, and the kinetic energy they gain depends on the voltage. How the equation for that is how much work is being done on the electron, that will result in the gain in kinetic energy. So work done on the electron. So think about the equation that we saw recently, potential difference. What is the equation we saw recently? Potential difference is equal to work done divided by charge, right? So what is the work done in that case? Work done is equal to charge times the voltage. So the work done on the electron here will be how much voltage that has been applied times the charge of the electron. And then gain in kinetic energy, you know already the equation for kinetic energy. So here, this E is same as this Q, the charge of an electron. In this case, it is the charge of an electron. This V is the voltage that you have applied. M is the mass of the electron, and V is the speed that it gets. So based on this equation, if they're asking you for the speed, rearrange it to find V. If they're asking you for the voltage, rearrange it to find capital V. Okay. Again, to make sure that you have understood how to apply this equation, page 144, summary questions 2 to 5 for practice. Okay. So with that, my PowerPoint is coming to an end. So for the rest of the lessons, you have 3 things to do. So make a note of it. 1, write volt in base units. Okay, write volt in base units. Second, what you saw in the previous slide about the summary questions on page 142, question 1 to 6, and then now summary questions on page 144, question 2 to 5. Okay, so I repeat. Question 1, express volts in base unit. Question 2, summary questions page 1 to 6. Summary questions 1 to 6 on page 142, and finally summary questions 2 to 5 on page 144. With that, I'm coming to the end of the lesson, Year 12s. I know this is not the most effective way of doing it, but I hope you will understand that I'm trying my best. Okay, hopefully if I teach you Friday, I'm hoping I'll be back in school on Friday. Otherwise, see you next week. Till then, if you have any concerns or queries, make a note of it, and once I'm back in the lesson, please ask. Take care, all of you. Bye-bye.